Okay, Assalamualaikum. Today we proceed with the qualitative predictors variable. So actually, qualitative predictor and also the polynomial adalah di bawah regression model for quantitative and qualitative predictors. In your textbook, it is on page in chapter 8. Okay, it is on page 313. Okay, so the qualitative predictor variable can be included into the multiple linear regression model actually. Okay, as mentioned here, as well as quantitative predictor variables can be used in regression models. Many predictor variables of interest in business, economy, and of social and also the biological sciences are qualitative. For example, qualitative predictor variables adalah gender, which is we have nominal ataupun categorical data, male and female, purchase status, whether purchase or not purchase, disability of the status, whether it is not disabled, partly disabled, or fully disabled. So any data that have the categorical ataupun level between them dipanggil qualitative predictor. Okay, qualitative predictor maksudnya variable untuk independent variables ataupun predictor variables lah. Okay, so qualitative variable is categorized by with the predictor variables. Dalam regression, our regression model lah. So Y kita is still the quantitative variable. Tapi kita punya all the X independent variables can be a mix between qualitative dan quantitative. Okay, so qualitative predictor variable ni dipanggil boleh dipanggil qualitative dan juga dipanggil dummy variable. Alright, so for example, in a study of innovation in the insurance industry, an economist wished to relate the speed with which a particular insurance innovation is adopted. Okay, this is why. To size of the insurance firm. Size of the insurance firm adalah quantitative variable and the type of firm. Okay, type of firm. Type of firm ni adalah kategori ataupun nominal measurement. So ini adalah kita kategorikan sebagai qualitative variable. So the response variable is measured by the number of months elapsed between the time the first firm adopted in the innovation. Okay, ini dia punya response variable. Okay, the number of months elapsed. Okay, the first predictor variable, which is the size of firm, adalah quantitative and is measured by amount of total asset of the firm. The second predictor variable, which is the type of firm, adalah qualitative and is composed of two classes, which is sama ada stock companies ataupun mutual companies. So ada dua, sama ada stock ataupun mutual. Kita punya qualitative variable, which is the second variable of independent variable. Okay, in order that such a qualitative variable can be used in a regression model, quantitative indicators for the classes of the qualitative variable must be employed. So daripada qualitative variable, we have two category tadi, stock dan mutual company. So kita kena jadikan dia quantitative indicator. Daripada kategori tadi, kita kena jadikan dia quantitative indicator. So kena labelkannya dengan nombor juga. Biasa kita labelkan 0, 1, 0, 1, 2 and so on. Okay. So kita tengok yang ni, contoh yang dulu. Dia kata, there are many ways of quantitatively identifying the classes of the qualitative variable. We shall use indicator variable that take on the values of 0 and 1. These indicator variables are easy to use and are widely employed, but they are by no means the only way to quantify a qualitative variable. So ikut contoh kat sini, tadi kita punya qualitative variable ada dua level, which is stock dan juga mutual. So kalau kita represent the data like this, maksudnya kita create another two independent variable, x2 dan x3. x1 tadi adalah size of firm. Okay, x2 kita create another two variable. Okay, we create another two variable because of we have stock dan juga mutual tadi. X2 will be 1, 0, 1 untuk stock, 0 untuk otherwise. X3, 1 untuk mutual, 0 untuk otherwise. So, kita akan dapat this regression model. So, bila kita nak calculate, kan biasanya kita kena nak estimate the model, kena adalah value beta 0, beta 1, beta 2 and beta 3. So we can transform the data. Let's say kat sini dia bagi 4 observation. Let's say data kita transform ke dalam bentuk matrix. So dia akan jadi macam ni lah. So first column will be all the 1. Okay, this is the value of x1 dan x2. 1, 0, 1, 0 ini dia bagi contoh. The first two being the stock form sebab tu 1, 0, 1, 0. And the second two being the mutual form sebab tu 0, 1 and 0, 1. Okay, and then bila multiply x transpose dengan x, okay, multiply this two, you akan dapat ni. This. Okay. So dia kata kat sini, okay, the x transpose x matrix equal to the sum of the two last column so that the columns are linearly dependent. Hence, the x transpose x matrix does not have an inverse. So because of that, we cannot use this notation ataupun cara nak represent the qualitative variable here. Okay, so macam mana yang perlu kita buat adalah use this one. Once the qualitative variable have the two levels, then we need to create only one new independent variable. Kalau ada dua level macam tadi, stock dan mutual, ada dua level, so kita create only one independent variable. Let's say if we have the qualitative variable with three levels of the qualitative variable or qualitative category, so we need to create two new variables. Okay, nanti I tunjukkan. So yang ni kita tunjuk dulu macam mana cara nak create the new independent variable if the qualitative involve two level of category. Okay, so macam ni lah contoh tadi. X1 ni adalah kita punya quantitative variable, so tak ada masalah. Ianya adalah size of firm. Kita punya Y adalah times elapsed tadi for the innovation. And then satu lagi variable tadi adalah type of firm, which is stock dan juga mutual company. Because of the stock dan mutual company ni adalah satu variable, which is the type of firm. Ada dua level of category, so we need to create only one independent variable. Okay, so we can define one if stock company and 0 if mutual company, but if you want to change 0 and 1 kat sini tak ada masalah. Okay, it depends macam mana kita nak represent the data, tapi interpretation nanti berbeza lah. Okay, so we have this function. We have this function ataupun model. Okay, x1 adalah size of firm dan x2 adalah type of firm tadi, sama ada stock company ataupun mutual company. 1 for stock, 0 for mutual. Alright, so we have that. So untuk dapatkan mean of the response variable, dia panggil mean response. So it will be like this. Kan? Dah biasa tengok bila mean response, so tak adalah kita punya error term kat sini. So it will be beta 0 plus beta 1 x1 dan beta 2 x2. Alright. So dia kata kat sini, okay, to understand the meaning of the regression coefficient in this model, consider the first case of a mutual firm. For such, x2 equal to 0. Okay, in case of the mutual firm, okay, kalau that company adalah daripada mutual firm, so x2 here will be 0. So we can replace x2 0 in this, regression model. So x2 will be 0, so akan dapat beta naught plus beta 1 x1 sahaja. Ini adalah mean response bila kita pilih mutual firm. Okey. Contoh pula, kalau x2 is 1 for a stock firm, okay, x2 equal to 1. So when we replace x2 here with 1, so you akan dapat beta naught plus beta 2 here. So this plus beta 1 x1. Okay, ini adalah mean response bila kita pilih stock firm. Kalau you tengok both of this, okay, dia punya slope equal beta 1. Kedua-duanya will have the same slope, tapi kita punya intercept berbeza. This one beta naught, this one beta naught plus beta 2. Okay, so kalau kita buat, okay, here, kalau kita buat straight line kan, kita akan dapat macam ni lah. Slope yang sama sebab tu selari, tapi intercept berbeza. This one untuk intercept beta naught sahaja. This one will be beta naught plus beta 2. Okay. Kat sini, contoh kat sini, looks like the intercept, the slope is negative, right? Kita tengok dia punya data. Okay. So, macam mana pula cara nak interpret the coefficient of beta 2? Okay, tadi x1 adalah our quantitative variable. So, nak interpret beta 1 macam biasa, macam you nak interpret the coefficient when in multiple linear regression, which is, we can say that when x1 increase by 1 unit, okay, so kena bagi sebutlah unitnya berapa kan, then the mean of y will also increase or decrease, depends pada sign kat sini, positif atau negatif, okay, by beta 1 unit, okay, when the other variables, which is x2, is held constant. Okay, itu cara you nak interpret quantitative variable. So, sekarang because of x2 adalah our indicator variable ataupun qualitative variable ataupun dummy variable. So, how to interpret the coefficient for beta 2? Okay, so ada dekat sini actually. Alright, so dia kata, we see that the mean time elapsed before the innovation is adopted, which is the mean response, y. Okay, mean times elapsed adalah y. A linear function of size of firm, okay, x1, with the same slope beta 1 for both types of firm, beta 2, types of firm. Okay, alright. So, beta 2 will indicate, beta 2 adalah coefficient untuk x2 tadi, type of firm. Beta 2 indicates how much higher or lower depends pada the sign dekat sini, sama ada positif atau negatif. Okay, the response function, which is y. Okay, how much higher or lower the response function for stock firm, then mutual firm. Stock firm, then mutual firm. Kenapa kita sebut stock firm dulu? Sebab kat sini, we denote one adalah stock firm. So, sebab tu kat sini, kena interpret how much higher or lower the response function for stock firm, then mutual firm. And then, kena tambah kat belakang ni sebab MLR kan, multiple for any given size of firm, which is X1. Okay, so how much higher or lower the response function for stock firm than the mutual firm? Beta 2 tu. Value of beta 2 tu indicate how much higher or lower. Okay, kena sebutlah berapa banyak higher, berapa banyak lower. Okay, for any given X2. Kalau kat sini positive, so kita katakan how much higher lah. Kalau negative, how much lower. So secara general, beta 2 shows how much higher or lower the mean response line for the class coded 1 than the line for the class coded 0 for any given level of X1, which is X1 adalah quantitative variable. Okay. So let's see the example with the figure. Okay, contoh yang sama tadi, Y adalah time elapse. Okay, insurance innovation tadi. The economist studied 10 mutual firms and 10 stock firms. So semua sekali 20. The basic data are shown in table 8.2. The indicator coding for type of firm in column 4. Note that X21 adalah stock firm and X20 adalah mutual firm. Okay, so this is the data. Ada 20 data altogether. This is the column untuk Y. Ini column untuk X1, which is the quantitative variable for independent. Dan juga ini adalah these two column kat sini adalah untuk qualitative variable, whether the firm is from mutual ataupun stock firm. Okay, so kita akan gunakan salah satu untuk nak run data nanti. You kena gunakan this column sebab kena tukarkan ke dalam bentuk quantitative term, which is daripada kita tukar tadi kan we have one new variable X2, 1 sebagai stock dan 0 sebagai mutual. So yang ni kita tak masuk lagi. Okay, so bila regreskan Y dengan X1 dan X2, okay, we regress Y with X1 and X2, which is kita masukkan kalau dalam SPSS ataupun dalam SAS EG, okay, we define this Y sebagai dependent, this X1 dan X2 kat sini, column, these two column, sebagai independent variable. Okay, so bila kita run, kita akan dapat kita akan dapat this ANOVA table dan juga regression coefficient table. So daripada sini kita boleh tengoklah dia punya beta 0, beta 1 dan beta 2. So from that we can create this regression model. Okay, we can create this regression model. Okay. And then you should know how to interpret this coefficient. Coefficient untuk beta 1 tak ada masalah kan? You can say that macam biasalah kita boleh katakan when X1 adalah apa ni? Apa tadi X1? X1 adalah size of firm kan? Okay, when size of firm is increased by one firm, so the time elapsed, okay, will be decreased. Sebab kat sini negative, will be decreased by 0.10174 unit when the other variable, which is the type of firm, is held constant. Okay, itu cara interpret beta 1, which is the quantitative variable. So macam mana you nak interpret value 8? Beta 2 tadi. Beta 2 adalah positive 8.05547. How to interpret this value? Okay. So macam tadilah kita akan katakan Y will be berapa banyak higher or lower, okay, for stock firm dan mutual firm. Kenapa saya sebut stock firm dulu? Sebab 1 tadi kita coded as stock firm. Okay, so macam mana nak interpret this value? We can say that the Y adalah the elapsed time for innovation to be adopted is 8 month higher. Unitnya adalah dalam bulan kan tadi. So kita katakan the elapsed time for innovation to be adopted. Okay, boleh tengok balik di dalam your textbook tu. Yang tadi kan, page 313 is, okay, berapa banyak higher or lower sebab dia positive, so higher. Okay, is 8 unitnya month. Is 8 month higher than, is 8 month higher for stock firm than mutual firm. For stock firm than mutual firm. Tak habis lagi. Kena bagi tahu the other variable tu. For any given size of firm, which is our X1. Okay. Ataupun kalau you nak sebut mutual firm dulu boleh, tapi kat sini will be lower lah. Let's say you nak sebut mutual dulu, you boleh katakan the elapsed time for the innovation to be adopted is 8 months lower for mutual firm than stock firm for any given size of firm. Tak ada masalah. Okay, sebab kat sini dia positif untuk stock firm. Sebab stock firm kita represent sebagai 1 tadi. Okay. Alright. And then kita ada model ni kan. Bila nak check the significance of the model, macam biasa boleh gunakan F-test. So you punya hash note macam biasa nak check significance of the model, it will be beta 1 equal to beta 2 equal to 0. So kita ada dua kan tadi, hash 1 not all beta 1 beta 2 equal to 0, dan gunakan F-test. Comparekan dengan F value from critical value from F table. Okay, so kat sini dia ada sampai sini saja, boleh cari nilai F macam biasa. Ini ANOVA table, so last kali dapatkan nilai F. Okay, boleh check. So bila reject hash note, we can say that the model is significant. Okay, and then we also can test for the individual. Test macam biasa, boleh juga test untuk individual, gunakan T value kan, gunakan T value. Kita check untuk beta 1 dan beta 2 biasanya. Okay, kita boleh check untuk beta 1 dan beta 2. Beta 1 kita boleh check macam biasa, kita tengok whether this variable is significant or not. Kita test untuk beta 1 equal to 0 dan beta 1 not equal to 0, gunakan t-test dan comparekan dengan a critical value from T table. Okay, so if we reject hash note, means that beta 1 not equal to 0, so we can say that the variable of x1 tadi is significant and should be included in the model. Okay, so macam mana pula nak test untuk beta 2? Sebab kita tahu beta 2 ni adalah coefficient untuk indicator variables. Okay. Okay, yang ni. Kita test untuk beta 2 equal to 0. Beta 2 not equal to 0. Kita nak test untuk, okay, to test the significant difference. Sebab beta 2 ni adalah coefficient untuk indicator variable 1 stock firm, 0 mutual firm. So kita boleh tengok untuk kita boleh test for the significant difference in Y between stock dan juga mutual firm. Okay, to test the significant difference in y, okay, in y in your response variable, macam yang ni tadi, time elapsed between stock dan mutual company ataupun mutual firm. Okay, kita nak tengok the significant effect in y between stock dan mutual company. Okay, so macam biasa, ini kita punya hypothesis testing, and then gunakan value T lah. Okay, T statistic, this is the T statistic, 5.52 tadi, and then comparekan dengan T table. Okay, comparekan dengan T table. Okay, so because of this is two-tailed test, macam biasalah, kena T tu alpha over 2 and minus P. Okay, so compare. Bila reject hash not maksudnya bila T statistic, absolute value of T statistic more than or equal to the value from the T table. Okay, we reject hash not. If reject hash not means that beta 2 not equal to 0, maksudnya kita boleh conclude that there is significant difference in response variable between stock dan juga mutual company if we reject hash not. Okay. Okay, so that is the concept of test for the coefficient of indicator variable. Okay, and usually we also can find the confidence interval, right? We can find the confidence interval. So macam biasa actually, nak dapatkan confidence interval untuk beta 2 plus minus T alpha over 2 and minus P multiply dengan standard deviation untuk beta 2. So ini value beta 2 tadi, ini value beta 2 8.05547 plus minus, this is the nilai from the T table, and ini adalah standard deviation untuk beta 2. Okay, boleh dapat daripada sini. Okay, so lastly we will get this two value. So macam mana kita nak interpret this? Okay, we can say that with 95% confidence, we conclude that the stock company tend to adopt the innovation somewhere between 5 and 11. Okay, approximate the value kat sini. So between 5 and 11 months on the average, then mutual company for any given size of firm. Okay, so this is the way how you interpret the confidence interval untuk beta 2, ataupun we also can say that we are 95% confidence that the insurance adopted for stock company is between 5 and 11 a month more than mutual company. Okay, lebih sebabnya kita sebut stock dulu kan, dan ianya positif, sebab tu more than the mutual company. Alright, so that is the way how you interpret dan juga cari all the coefficient dan juga confidence interval. Okay, I nak tunjuk pula macam mana cara nak create the new independent variable when the level for the qualitative variable tadi adalah more than 2 classes. Okay, let's say kat sini, if a qualitative predictor variable has more than 2 classes, we require additional indicator variable in the regression model. Consider the regression of the toolware and tool speed and tool model. So ada 3 variable kat sini sebenarnya. Toolware adalah Y, tool speed adalah X1, tool speed adalah quantitative variable, dan tool model adalah qualitative variable, which is we have 4 classes, M1, M2, M3 dan M4. Ada 4 classes. So macam mana kita nak create the indicator variable? Okay, so because of we have 4 classes, we need to create 3 new independent variable, x2, x3, and x4. So we create x2, 1 if tool model is M1 and 0 otherwise. X3, 1 if model is M2, 0 otherwise. And X4, 1 if model is M3, 0 otherwise. So macam mana? Dia actually ada satu lagi kan, M4. Okay. So bila X2, X3 and X4 is 0, 0, 0, 0, then we consider that model adalah from M4. Okay. So this is our regression model. Beta naught ni adalah beta 1 adalah koefisien untuk tool speed. Okay, our new variable ada x2, x3 and x4. So kita ada beta 2, beta 3 dan beta 4. So ini illustrationnya. Bila kita pilih tool model M1, x2-nya will be 1, x3 0, x4 0. Bila kita pilih tool model M2, x1-nya 0, kan kita pilih model M2. So x2 0, x3 1, x4 will be 0. Bila kita pilih model M3, x2 will be 0, x3 0, and x4 will be 1. Okay, bila kita nak pilih M4, model M4, so all of this will be 0. x2 0, x3 0, and x4 will be 0. Okay, bila kita masukkan dalam equation response function dekat sini, okay, when we choose M4, so all the x2, x3, x4 is 0, so kita akan dapat this function. Setuju? All this 0. So dapat this function. Bila kita nak pilih M1, M1 tadi adalah 1 untuk x2. Tadi kan x2 1, x2 1, x3 0, x4 0. So, kita masukkan kat sini. Replace x2 with 1, x3 0, x4 0. So, you akan dapat beta 2 kat sini. So, beta naught plus beta 2 plus beta 1 x1. Okay. And then, kalau kita nak pilih M2 0, x3 will be 1. Yang lain will be 0. So, sebab tu beta naught plus beta 3 plus beta 1 x1. Untuk tool model M3, x4 will be 1. x2, x3 is 0. So, because of that, kat sini will be beta naught plus beta 4. So, kalau tengok all these 4 equation, beta 1 dia semua sama. Slope-nya sama, cuma intercept yang berbeza. So, macam mana kita nak interpret the beta, all the beta here. So, beta 1 tak ada masalah. Kita interpret macam biasa sebab x1 adalah quantitative variable. So, macam mana interpret beta 2, beta 3 dan beta 4. All of these 3 adalah qualitative variable. So, x2 adalah represent 1 for M1. x3 represent 1 for M2. x4 represent 1 for M3. So, we can say that. Okay, the coefficient beta 2, beta 3 and beta 4 indicate that how much higher or lower, depends pada sign positive atau negative, the response function for tool M1, M2 and M3 are then for the tool model M4. Sebab semua ni kita comparekan dengan M4. Kita comparekan M1 dengan M4, M2 dengan M4 dan juga M3 dengan M4. So, let's say kita nak interpret beta 2 saja. Okay, we can say that. So, we can say that the response function is beta 2 value dia, which is beta 2, berapa dia punya unit, higher or lower, tengok dia punya value negatif ke positif. Higher for the M1 model, then M4 model for any given for any given, the other variable adalah x1 tadi, for any given tool speed. Faham tak? Kalau beta 3 pula, kita boleh katakan the response variable, okay, unit ni kena sebut unit ni lah. The response variable is beta 3 higher or lower. Okay, is beta 3 higher or lower, berapa banyak lah unit dia beta 3. Is beta 3 higher or lower for beta 3 tadi. Okay, beta 3 ada belong to x3. Is beta 3 higher for M2 model than M4 model for any given tool speed, which is x1. Okay. Macam mana pula nak interpret untuk beta 4? Macam sama je juga, cuma kita comparekan beta 4, kita compare pula M3 dengan M4. Okay, we can see that the response variable is beta 4 higher or lower for M3 model than M4 model for any given speed, for any given tool speed x1. Okay. Okay, so that is how you interpret all the coefficient bila kita involve more than 2 level. Okay, so semua all this value of coefficient beta 3, beta 2, beta 3 and beta 4 ni kita compare dengan M4 saja. M1 dengan M4, M3 dengan M4, M2 dengan M4. Kita boleh tengok berapa banyak higher or lower kan antara all this model dengan M4. Macam mana pula kalau kita nak tahu perbezaan antara contohnya M1 dengan M2, M2 dengan M3 contohnya. Okay, so actually boleh, which is you kena cari difference between beta 4 dan beta 3. Contohnya, measure how much higher or lower the response function for tool model M3 than response function for tool model M2. Kenapa M3 dengan M2? Sebab before adalah, okay, before kat sini, before 1 untuk model M3 and B3 adalah 1 untuk model M2. So because of that, kita boleh compare how much higher or lower the response function for model M3 than model M2 for any given level of tool speed. Okay, so boleh juga nak compare dengan nak comparekan M1 dengan M2 pun boleh. Nak comparekan M1 dengan M2. So, you boleh buat beta 2 minus beta 3. So, you boleh tengoklah value-nya positif ataupun negatif. Alright. Okay, let's see example from the other questions. Okay, let's see this. Okay. An economist is analyzing the income of the professional physician, dentist, and lawyer. He realized that an important factor is the number of years of experience. However, he wants to know if there are any difference among the three professional groups, physician, dentist, and lawyer tadi. He takes a random sample of 1 to 5 professional and estimate the MLR model. So this is the MLR model. Beta 1 adalah coefficient untuk years of experience. Dan we create another 2 independent variable, okay, which is x2. Represent 1 if it is physician, 0 if lawyer. Kenapa saya sebut lawyer? Sebab kat sini ada 3 sebenarnya, physician, dentist dan lawyer. X3, 1 if it is dentist and 0 if it is lawyer. The output. So kat sini ada output. Bila kita regress Y dengan X1, X2 dan X3. Dan ini adalah ANOVA table. So let's say nak cari the first question, estimate the regression model. So just kita boleh terus ambil daripada sini kan, coefficient table. Okay, soalan B, test the model's utility, means that kita nak test untuk model significance of the model. So this is the hypothesis. Okay, F boleh ambil daripada ANOVA table dan juga dan compare dengan F table. Okay, dia gunakan kat sini alpha 0. Oh salah ni, sebenarnya kat sini guna 0.05. Sepatutnya kat sini pun 0.05. 3121. Okay, tengok daripada sini je. 3121. Okay. So kat sini hash not is rejected. So regression model is significant. Lepas tu dia check pula, is there enough evidence to conclude that the income and the experience are linearly related. So experience tadi adalah kita punya X1 kan. So sebab itulah kita test untuk beta 1. Okay. Nak tengok linear ke tidak, related ataupun tidak, ada relationship or not. So kita test untuk beta 1 0, beta 1 not equal to 0, gunakan T statistik tadi kat atas dan comparekan dengan T table. Ni two-tail test 0.05 divided by 2. Okay, dan N minus P. Okay, so kat sini hash not is rejected. So we can conclude that there is enough evidence to indicate that the income dan juga experience Y dan X1 are linearly related. Okay, tengok soalan ni. At 1% level of significance, is there enough evidence to conclude that the physician earn more on average than lawyer? Okay, physician yang mana tadi? Physician. Kalau tengok balik, physician adalah X2. X2. Okay, lawyer tadi bila X2 0, X3 0. So, kita boleh ambil value beta 2. Kita boleh test untuk beta 2. So, sekarang dia nak tahu physician earn more than lawyer. So, sebab itulah kita test untuk beta 2 more than 0. Kalau dia nak test hanyalah nak test untuk nak tengok ada difference ke tidak. Okay, any significant difference in income between physician dan lawyer. So you just boleh testkan beta 2 equal to 0, beta 2 not equal to 0. Kalau just nak tengok any significant difference of the income between these two position, physician ataupun lawyer. Tapi sekarang ni sebab dia nak tengok whether physician earn more than lawyers. So sebab itulah kita test untuk beta 2 more than 0. Sebab beta 2 1 we represent 1 untuk physician. Kalau kat sini dia kata kita nak test conclude that lawyer more than physician. Okay, lawyer more than physician. So, sepatutnya kita akan test beta 2 less than 0 lah. Maksudnya, physician less than lawyer. Faham tak? Okay, so T macam biasa boleh ambil daripada table. Okay, T value, test statistik. Cuma dekat sini, kalau kita dekat sini, ini adalah one tail test. So, it will be T alpha. Okay, N minus P. Alpha bukan alpha over 2 sebab ini adalah one tail test. Kalau yang ni two tail test. Kalau yang ni kita nak compare kena alpha over 2 lah. Okay. So tengok bila value test statistic more than the value critical value. So because of that hash not is rejected. Bila hash not is rejected we conclude beta 2 more than 0. Means that there is enough evidence to conclude that the physician are more than lawyers. Okay. So that is the way how you doing this test. So bolehlah juga kalau nak check whether the income for apa tadi for dentist more than lawyer. Okay, so kita test untuk beta 3 more than 0. Kalau nak test whether dentist lower than lawyer, so it will be beta 3 less than 0. Okay. Alright. So ini pula dia nak you interpret coefficient untuk X2. X2 tadi 1 for physician, 0 untuk lawyer. So it means that if the person is physician, okay, the income will increase by 10.160, okay, more than lawyer sepatutnya. When the other variable, which is the experience, held constant. Okay, so sekarang kat sini dia nak forecast the income of a lawyer with 18 years of experience. So X1 adalah 18 years. Lawyer, so maksudnya X20, X30. Kan? So because of that, it will be like this. Okay, sepatutnya kat sini. Plus beta 30, beta 20, X2, plus 0, X3, plus 0, X4. Kan? Sebab lawyer, sampai X3 sahaja. Sebab bila lawyer, X2 dan X3 is 0. So just replace X1 with X1 18 here, then you akan dapat 108.91. So we forecast that the income for lawyer with 18 years of experience adalah 108.91 in 1000 ni sepatutnya. Okay, yes, in 1000. Darab dengan 1000 lah sebab dia punya unit adalah annual income in 1000. So darab 1000 kat sini. So income dia will be 108,910 ringgit. Okay, bila 18 tahun experience. Okay, soalan last ni. Suppose another factor affecting income is location practice. That is, whether the professional is working in the city or out of the city. Maksudnya ada dua level. So how would you include the variable in the model? Kita nak include another variable. The new variable will be X4 because of the level of this category variable ada dua level. So kita create only satu sahaja independent variable. 1 if work in the city, 0 if work out of the city. So therefore the model will be like this. Tambah lagi satu variable X4. Right? So that is one of the example of the class.